Okay, guys, let's start with the homework number 4. This is your homework 4. Let's do this. It's still early in the night. Well, for the rhombus below, we're going to be finding the angle measures involving diagonals of a rhombus. For the rhombus below, find the measurements 1, 2, 3, and 4. And this is going to be really easy. Easy peasy lemon squeezy. Remember, a rhombus has congruent sides, which means that these opposites are going to be the same. So this number 42 is going to be the same as number 3. As we can see here, the angle number 3 is going to be 44 degrees. Now, where do we get the 48 degrees? Okay, you ask. This is because also a property of the rhombus, this angle is also going to be measuring 42, which means this 2 is also going to be measuring 42 degrees. Now, this whole angle and this whole angle are going to be measuring 180 degrees. So it's going to be the angle number 3 plus 42 plus 1 plus 2 are going to be 180 degrees. Angle 1 and angle 2 we can put it like 2 times angles 1, okay? So angle 3 is going to be again 42 degrees plus 42 degrees plus 2 times angle 1, and this is going to be 180 degrees. Why? Because a line divided this angle divided by this segment is going to be the same this angle and this angle. That is the that is the explanation. So this is going to be putting 2 times the angle number 1. That's going to be 180 degrees minus 42 minus 42. This is going to be 96. So it's going 96 degrees. So solving this is going to be angle number 1 is going to be 96 degrees over 2. So angle number 1 is going to be 96 over 2 is going to be 48 degrees. So by definition, angle 1 is going to be the same as angle 2, and it's going to be the same as angle 4. Why? Because they are alternate angles. This is the definition. Why they are the same. They are alternate internal angles. Okay? That's why angle 1 is the same as angle 2, and it's the same as angle 4, and they all measure 40 degrees. Now to the the definition of these ones. All the angles inside a parallelogram or a quadrilateral is going to be 360 degrees. So to solve for x plus 106 degrees, 101 degrees, okay, 101 degrees plus 92 degrees is going to be equal to 360 degrees. So x is going to be the 360 degrees minus 106 and 16 minus 101 degrees minus 92 degrees. Okay, so solving this operation is going to be okay, x is going to be 51 degrees, which is the answer to this one. Okay, now for this problem, it's going to be the property of rectangles. In the rectangle below, RB, meaning this one and this one, equals 2x plus 8. TB, this one, and this one equals how much? 6x minus 20. And the angle formed by the segments R, B, and U, meaning this angle, equals 64. Now they're asking us to find the value of S and B, this one, and B, T, and S, this angle. Okay, this is actually really easy. We need to know that this whole segment is the same, this part and this part are of the same length, so the segment RB is congruent to the side TB, so it is going to be 2x plus x equals 6x minus 20. So we're going to be solving this. We put all the x to one side and all the numbers to one side. It's going to be this one, minus 4x equals how much? Minus 28 equals is going to be minus 28 over minus 4 is going to be equal to 7. Okay, this is the value of x. X equals 7. Now we know that RB is going to be, this segment is going to be the same as this segment, SB. So we put it like this, RB, so it's going to be plus 8 is going to be equal to the segment SB. This is what they are asking of us. So it's going to be 2 times 7 plus 8 is going to be how much? 2 times 7 is going to be 14 plus 8 is going to be 22. And this is the value of SB. Okay? This is how we find SB equals 22. Now for the angles. The angles is going to be a little easier. We know that this angle here equals 64, right? And we know that by the property of vertical angles, this segment is also 64. Now we know that these parts are isosceles, meaning that these angles are going to be the same, of the same value. So we have the value of 180 degrees is going to be equal to 64 plus 2 times the value of, in this case is VTS. Now we solve for this. We can put it like 2 times VTS is going to be 180 degrees We only put these parts to the other side, don't worry. Minus 64. Now it is going to be BTS equals 180 minus 64 over 2, and BTS is going to give us the value of, again we put this in our calculator, that's correct, the angle of 58. And guess what? That is the correct answer. 58. Okay, to the next one. To the next one, we need to be proving that the sides of a parallelogram are the same size. Or we need to identify that this is a parallelogram. Remember, always the last definition is going to be definition of a parallelogram. Okay? Now we start. How do we start? By putting the given values. In this case, it is the segment A and B, and the segments C and D are congruent. Why? Because they are given, like this. The same as the segment A and D and BC. AD and BC. AB and CD. Okay, now they are asking us to be proving that by something else. In this case, as these sides, these triangles are the same, are together in this part, we can put that the segment B and D, in this case B and D, and again B and D are the same because of the reflexive property, because remember we can put these triangles like this, and these are the same size. Okay, that is the reflexive property. Now they are asking us to be proving that these triangles are the same. Remember, they are asking for the congruency. Remember the S and S congruency, side angle side, angle side angle, angle angle side congruency. Remember? Well, because we have the side that is the same, a side that is the same, and again another side that is the same, we put the S and S and S property. Now this is interesting. These properties means that congruent parts of congruent triangles are congruent. Look, as we can see, these parts of the triangle as well, they say that they are congruent because of the side congruency property. Now, this side that is 1 is going to be the same as this part of the triangle. So 1 equals to the opposite one, okay? 1 equals 3, meaning that 2 equals 4, okay? Why? Because of this property. Because they are congruent, we need to be putting this one as congruent, and they are the same. Now, using this property, if alternate internal angles are congruent, then the lines are parallel. In this case, they put us the first one, A and B, meaning this side is parallel to CD. Why? Because 1 equals 3. Because of this property, 1 equals 3, these angles are the same. This means that the same size of the the triangles of the parallelograms are the same, are equal, are parallel. Now that is the same from AD. Why? Because we compare its internal parallel signs. We need the 3 and the 1. They are the same, so internal internal parallels in alternal internal angles are the same, are congruent, then the lines are parallel. So AD equals to BC. AD equals to BC and AB equals to CD. And remember, the last part is the definition of a parallelogram. This is always the answer. Okay? Now we go to the next part. How to be solving this with the properties of parallelograms. They're asking us to know if these two parts are parallelograms. Remember, we need to have at least two parts. The first is two pairs that are opposite. In this case, this that has two lines, will need to be with this one. But as they are not the same, we cannot put that these two are the same angles because they do not match the specification. That needs two pairs of internal angles equal. This is one condition. Another condition is two opposite sides are equal. That's why these two are not parallelograms, because it will need that this will be equal to this one, but they are not equal. They have two lines here and one line here, two lines here and one line here. So they are opposites, but they are not equal. So it is correct. They are not necessarily parallelogram. Okay? Now the other condition. They need to be parallel. In this case, these segments are parallel. They do not cross each other. Why? Because the definition of a parallelogram is they need to have two pairs of parallel sides. They need to have two pairs. In this case, they have one pair right here, and because of its definition that they have this part that are opposite and the same side of this diagonal, they mean that these two, or well, this figure is a parallelogram. Also, these parts, they are opposites, they go each other without touching each other, they are of the same size, and this is pure logic, only theory, because they have these parts, they are, okay, these parts, they are not parallelograms. Why? Because if we can write these parts, they do not necessarily mean that they are parallelograms, because they are not of the same size. Okay, that is the definition of this one. Now we're going to the next exercise. Yes, this one. Remember, to be classifying quadrilaterals means, I'm going to be writing here, quadrilaterals means four sides. That is the definition of quadrilateral. So these three figures have three sides. They are quadrilaterals. Why? Because they have four sides. That is the definition of a quadrilateral. Parallelogram, they means they have sides that are always parallel. Parallel means they do not cross each other. Okay? This is a parallel. If we write these angles, these figures, we can see that they do not cross each other. Why? Because these four angles are of the same size. they can't, they are of the same size, so they can cross each other. They will be like this, okay? And we can see there are two pairs of sides that do not intersect each other. In this one is also a parallelogram. Why? Because of the theory. And in this case, it is not, because we can write these ones are, this one is here, and this one is here. We can put that these two angles are going to be intersecting each other here, and this one are going to be intersecting each other here. Because of this, these are not parallelograms, okay? That's why they are not parallelograms. And since they are not parallelograms, they are not rectangles. If they are rectangles, why? Because they have four right angles, because all their angles are of the same size. They are saying here. That's why they are rectangles. In this case, it's also true because its internal diagonals are of the same size, and they are saying that these two pairs are parallelograms. So that's why they are parallelograms and also rectangles. Remember, rectangles means four right angles. That is the definition of a rectangle. Now we're going to the next one. We need to identify parallelograms, rectangles, and squares. Remember, squares means four sides and same length. These are squares. A rectangle means four right angles. And a parallelogram, two pairs of parallel sides. In the first one, you can say they are here, they are here, so they are parallel, and they are parallel, okay? But they are asking squares. Remember, a square, four sides of the same length, and four rectangles. They have four rectangles, and also all its sides equal the same length. So only the figure 8 is a square. Now parallelogram, they do not intersect. They do not intersect here. They have one pair and two pair here that do not intersect. So the second one is also a parallelogram, and this one. These opposite sides do not intersect. And also these ones do not intersect. So all three are parallelograms. Now rectangles, remember, four rectangles. This one has four rectangles. The second also has four rectangles. But the third one do not, so this one does not have four rectangles, so the only correct answer is A and B. Okay? Now we're going to be classifying the quadrilaterals. The quadrilateral, remember, squares have all four sides are congruent, so this is correct, and they have four right angles. Okay, and since they are rectangles and squares, that means they are also quadrilaterals. That means they have two pairs of parallel signs. This is the square, remember. And four four equal sides. Now, parallelogram. We can define the parallelogram as this figure. They do not, all sides are not congruent because this one and this one are the same, but this one are not the same, so they do not have all four sides. They do not have all four right angles, so the second one is not a check. And they not have one pair, they have two. They have this pair of parallel sides, and these two of parallel sides. Okay, so the third one is okay. Now a trapezoid. A trapezoid is going to be this figure. Okay. Also is congruent? No, because the only congruent sides are these. These two are not the same. For rectangles? No, they are all acute. Only one pair of parallel sides. That is correct, because if we continue this side, this line, this side, they're going to be intersecting right here, so that means they only have one pair. This one pair, these two sides. So that is the definition how we classify quadrilaterals. Now classifying parallelograms. Remember, we have uh, the big one is a quadrilateral. A quadrilateral can be a parallelogram, meaning two pairs of sides, or a trapezoid, okay? And a parallelogram can be a rhombus, a rectangle, and a square. But the square at the end is the combination of these two. The combination of these two is going to be a square. So every square is a rhombus. That will mean yes. Why? Because a square means four equal sides, the same as a rhombus that has all four equal sides. That is the definition of a rhombus. Now, a rectangle with four congruent sides is a rectangle, is a square. That is correct, because remember, a rectangle has four right angles. But if those four right angles now has four equal sides, that means that that rectangle is a square. That's why it is true. Now, every rhombus is a parallelogram? Yes, because a rhombus is inside the parallelogram. Just for that definition, that means that this is true, okay? Because a rhombus is inside a parallelogram. Now, every quadrilateral is a rhombus? No, because the quadrilateral is the biggest expression of four sides. That doesn't mean that all rhombus are parallelograms. That would be the opposite. All rhombus will be quadrilaterals. Okay, not the other same. So that is false. Now to the last one. They are asking us to be considering the figure QR is seen as a parallelogram. We have this information and we need to find the following. Okay, we need to be finding x, the angle QRT, and angle Q. Okay, first x. X is this one. By the definition of parallelograms, that means that 6x, meaning this side, is the same as this side, so 6x equals 18. So x is going to be 18 over 6, x is going to be 3. Okay, that is the definition of x. That is correct. Now they're asking us to find the value of the angle in QRT, that meaning Q going to R and going to T. So this one. Now by the definition of internal angles, that means that this 31 is going to be the same as this angle. So QRT is going to be 31 degrees. And now the angle Q. That means the opposite sides, the opposite angles are going to be of the same value, meaning that angle in Q is going to be the same as angle in S. So angle in Q is going to be 130 and 13 degrees. And those three will be the answers for this operation and for this homework. Thank you for your attention. Have a nice day and good luck with your exams. Bye.